Hey there guys. In this video we're going to look at how to factor algebraic expressions. Factoring basically means, in this case, undoing the distributive property. So if you look at these expressions I have written in this box, before today if you saw 2 times the quantity x plus 4, we would have known to distribute that 2 to the x and the 4 to get 2x plus 8. Well, today we're reversing that process, and so we're going to be starting with an expression like this, 2x plus 8, and going back to the expression 2 times the quantity x plus 4. And we're going to do that with the following steps. The first step is we're going to find the greatest common factor of each term. For this example here, our terms are 2x and 8. Well, if you look at the coefficients 2 and 8, the greatest common factor of 2 and 8 is 2. It's the largest number that goes into both 2 and 8 equally. So if we divide each term by the GCF, 2 divided by 2 is a 1, so you get a 1x, and 8 divided by 2 is 4, so you get a 4. That's how you determine what goes in parentheses. Okay, so we're going to practice that now with the following examples, so this makes a little bit of sense hopefully by the end of the video. So number 1, we have 4k plus 20. So to factor this expression, I'm going to look at the coefficients. That would be 4 and 20. 4 and 20, the GCF of those is 4, so I'm going to place a 4 here on the outside of my parentheses. And so now I'm going to think, what times 4 would have given me 4k? Well, k times 4 would have given you 4k, so that goes as my first term. And then what times 4 would have given me 20? Well, 5 times 4 gives me 20. So on the inside of my parentheses is going to be a k plus 5. So you're basically just undoing the distributive property here. And you can think about that as dividing, since the distributive property is multiplying. 4k divided by 4 gives you k, and 20 divided by 4 gives you 5. So this is my answer. This is the factored form of this expression. If you want to check your answer, well then you just need to distribute. 4 times k is 4k, and 4 times 5 is plus 20, so that gives you our original problem. Okay, number 2, 5m minus 15. So we look at the 5 and we look at the 15 and we think, what's the GCF of 5 and 15? That would be 5. And so then we're dividing each of these terms by 5. So we're thinking, what times 5 gives us 5m? That would be m. And what times 5 gives us negative 15? Well, that would be negative 3. So this factored form of this expression is 5 times the quantity m minus 3. Number 3, 6r minus 48s. Okay, when there's more than one variable involved, you still do the process the same. We just look at the coefficients, 6 and 48, and we think, what's the GCF of 6 and 48? Well, the GCF of those two is 6, so 6 goes on the outside of our parentheses. And then what times 6 is 6r? Well, that would just be an r. What times 6 is a negative 48s? Well, negative 8 times 6 is negative 48. And then to get the s, we just need to put an s with that negative 8. So 6 times the quantity r minus 8s is the factored form of this expression. Number 4, 12w plus 24. The GCF of 12 and 24 is 12. And so I'm undistributing now. What times 12 is 12w? That would be w. And what times 12 is 24? Well, that would be a plus 2. So factoring this expression gives me 12 times the quantity w plus 2. For number 5, I have 2p minus 9. Well, if you look at 2 and 9, the only GCF of 2 and 9 is 1, and it's kind of silly to write a 1 on the outside of your parentheses because we know from our identity property of multiplication that anything times 1 is itself. So anytime your GCF of your coefficients is 1, that just means that your expression is prime. We cannot factor that expression, so we just write the word prime. Number 6, 10v plus 45. So the GCF of 10 and 45 is 5. So 5 is going to go on the outside of my parentheses. And now we think what times 5 is 10V? Well, that would be 2V. What times 5 is 45? That would be 9. So this becomes 5 times the quantity 2V plus 9. Number 7, 16A minus 12B. The GCF of 16 and 12 is 4. So we think what times 4 is 16A? That would be 4A. What times 4 is negative 12B? That would be a minus 3B. Number 8, 8R plus 15. Well, the GCF of 8 and 15, if we think about that, it's 1. So because the GCF is 1, this would also be a prime expression. Okay, to the back side, number 9 says, a question on a quiz asks students to factor the expression 32m minus 24. And you have Ryan and Jane here who both gave answers. We need to explain who is correct and why. So take a moment and look at Ryan's and Jane's answers and see if you can figure out who is correct and why. Okay, so if you said Jane is correct, you're right. The question now is, why is Jane correct? Well, if you look at Ryan's answer, he put a 4 on the outside of the parentheses, whereas Jane put an 8 on the outside. The GCF of 32 and 24 is 8, not 4. 4 is a factor of 32 and 24, but it's not the greatest common factor. So that's the reason why Ryan is incorrect. Okay, when we're factoring, we need to factor out the greatest common factor of our coefficients, and Ryan did not do that. Okay, last few examples. What we're going to do for these is we're going to first simplify each of our expressions, and then we're going to factor them. Notice these are two different sets of directions. Simplifying and factoring are not the same thing, so that's why it's listed as two separate steps. So we're going to distribute and combine any like terms first, and then once we do that, we're going to factor if possible. So number 10, negative 13 plus 11m minus m plus 5. To simplify this expression, I'm going to combine my like terms. So we have negative 13 and positive 5. Negative 13 plus 5 is negative 8. And then for the variable terms, we have 11m minus 1m, and that gives us a positive 10m. So we get negative 8 plus 10m, or we can rearrange that as 10m minus 8. When we're factoring, I think it's easier to put the variable term first, so that's why I'm reordering this. So this expression here is simplified, 10m minus 8. So now to factor, this is where I need to undistribute, and so I think of my GCF. What's my GCF of 10 and 8? Well, the GCF of 10 and 8 would be 2. So we put a 2 on the outside, and then we think what goes on the inside. What times 2 is 10m? That would be 5m. And what times 2 is negative 8? That would be a minus 4. So the factored answer here is 2 times the quantity 5m minus 4. Okay, number 11, I'm going to start by combining my like terms again. So 7x plus 11x is 18x. And negative 2y minus 8y is negative 10y. So we get 18x minus 10y. So now this expression here is simplified. Now I factor. I think, what's the GCF of 18 and 10? Well, the GCF of 18 and 10 would be 2. And so if we factor out a 2, what times 2 is 18x? That's 9x. What times 2 is negative 10y? That's negative 5y. So 2 times the quantity 9x minus 5y. Number 12. So to simplify this expression, I first need to distribute. 5 times 3a is 15a. 5 times negative 2 is negative 10. And then we bring down everything else. Next, we combine our like terms. 15a minus 13a gives us 2a. And negative 10 minus 2 gives us minus 12. So this is simplified to 2a minus 12. And now we factor. The GCF of 2 and 12 is 2. A times 2 gives us 2a, and a minus 6 times 2 gives us our minus 12. So this factors into 2 times the quantity a minus 6. Number 13, I need to distribute this negative sign to both the 4k and the negative 17. So this becomes minus 4k plus 17. I bring down the 1 and the plus 24k. Combine like terms. My 1 and my 17 combine to get 18. And my 24k combines with the negative 4k to get a plus 20k. So we get 18 plus 20k, or I can rearrange that and make it 20k plus 18. And now we factor. The GCF of 20 and 18, you guessed it, it's 2. And what times 2 gives us 20k? It's 10k. What times 2 gives us 18? It's 9. So 2 times the quantity 10k plus 9. By the way, don't always assume your GCF is 2. 2 is often a common answer for greatest common factors, but it's not always the greatest common factor. So just be careful of that. Okay, the last two examples, 14 and 15. I'm going to pause the video now and have you try those on your own. And once you think you have answers for those, click play to check. And let's check our answers here. For number 14, if you distribute first, you get a negative 3m minus 18n. Combine like terms to get 6m minus 24n. And then your GCF in this case is not 2, it's 6. So this expression factors into 6 times the quantity m minus 4n. Finally, for number 15, we distribute to get a negative 6r minus 8s. Combine all of the like terms to get 14r minus 6x. And then your GCF again is 2 for 14 and 6. So it's 2 times the quantity 7r minus 3s for the factored form. Okay, any questions you had over this video, make sure you write those down so that you can ask those the next time you're in class. Until then, have a nice day. You're all wonderful people.